In Module 1, Lesson 1, we were introduced to the concept of ratios. A ratio is a comparison of two values. Ratios can be written in 4 different ways. Ratios are written in simplest form. This is a big piece. A lot of kids forget the simplest form piece, so that's important. Make sure all of your ratios are written in simplest form. So here are some examples. For every girl on the soccer team, there were four boys. These are ratio words that you're going to hear a lot. For every, there are. These are the ratio words that we look for. So what this means is I'm going to have a soccer team. On that soccer team, there's one girl, and there will be 4 boys. What this means is if I want to keep the ratio the same on this soccer team, if I'm going to add one person, I have to add in the same ratio. So if I want to add more people to the team, I would have to add 1 girl and 4 more boys. So each time I'm increasing the number of teammates, I have to keep the ratio the same if I want that ratio to be the same. So for every 1 girl, there are 4 boys. So we can write this ratio in a bunch of different ways. If we want to write the ratio of girls to boys, one thing to keep in mind is that ratio order is very specific. If it's telling me to write the ratio of girls to boys, the number of girls has to come first, the number of boys has to come second. So the 4 different ways to write it, the first one is with a colon. So if I'm writing the girls to boys, it would be girls, colon, boys. So the number of girls, colon, the number of boys, and that colon is those 2 dots. So for every girl means 1 girl. So I would put this as 1. And the number of boys is 4. So this is a 1 to 4 ratio. And again, that's girls to boys in that specific order. Another way that you can write this is with the word to. So now we're just doing girls, the word to, boys. And it all means the same idea. It's just different ways to write it. The next one is a fraction, girls to boys, or 1 to 4. And then the last one is a tape diagram. And a tape diagram is just a drawing of boxes. So you would draw 1 box for the number of girls. And then underneath that, and I do it lined up and directly touching, I would put 1 for the boys and then extend that box to create the 4 boxes I would need. So I've got 1 box for the number of girls, 1, 2, 3, 4 for the number of boys. So those are the 4 different ways that you can write that ratio. So if I want to do a different ratio with this same idea here, the next one's asking me to write the ratio of boys to girls. So now the order has switched, which means our numbers are going to switch. If I'm going to write it with a colon, it's now boys to girls. So this would be 4 to 1. I can do it with the word to, boys first. Boys to girls, or 4, the word to, 1. With the fractions, that would be boys over girls, or 4 over 1. And then with the tape diagram, it would just put the 4 on top and the 1 on the bottom. Okay, so just notice the difference there. We have girls to boys first and then boys to girls. So order is extremely important. And all of these are in simplest form, so that's why they're good to go as is. The next one we're going to do is write the ratio of boys to the total number of players. So now we're doing boys to total. So when you're looking at total, you're going to add all of them together. So however many girls there are in the ratio to however many boys there are in the ratio. So if I have 1 girl and 4 boys, all together that makes 1, 2, 3, 4, 5. So our total is 5. So the number of boys is 4 still, and then the total is 5. So the ratio of boys to the total players on the team is 4 to 5. That goes the same for however you write it with the word 2 as the fraction and as your tape. Oops. And again, notice I'm lining these up. The first 4 are fairly lined up. And then we have that out piece. That's going to be important when we do get to tape diagrams. And then the next one is just writing it as, we're missing the word 2 here, girls, 2 total. I find it really helpful too when I'm writing ratios to do this underlining, circling the word 2, and then underlining the next piece of the ratio I'm looking for. So now I'm doing girls to total. There was 1 girl, still the same total, still 5. So girls to total with the word 2, girls over the total, or girls to total that way would be 1 over 5. And then again, as the tape, 1 girl. I'm going to line up that first box and continue on to make the rest. Typically, we want our boxes to be the same size. I know it's a little difficult as 6th graders to do that, but as best we can. Okay, so that's how it works with a ratio. A lot of the times in 6th grade, we look at ratios with a colon or with a fraction or with a tape diagram. Not too much with the word 2, but it's always fine to do it that way. On homeworks, it is pretty specific to how to write it, which to use, whether to use the word 2 or the colon. So just pay attention that you're reading the directions carefully. Okay, example 2 says for every, so there's those ratio words for every, and we've got 9 tablespoons of sugar in a recipe. There are 12 tablespoons of flour. Notice I'm underlining and squiggly underlining things to help me read my problem. I think that's a really great idea. Those for every, there are our ratio words, and then the numbers in the ratio I underline. So the first piece asks for the ratio of sugar to flour. Okay, so I'm going to go ahead and write this in the 4 different ways that we've seen. So if we're doing sugar to flour, the number of sugar are 9. The number of flour are 12. That's with the colon. Now, one thing to notice is this ratio is not in simplest form. In order to put a ratio in simplest form, you would want to make sure that the 2 numbers don't have a common factor, so they can't be divided by a common number. If I look at 9 and 12, they can both be divided by 3. So what I'm going to do is I'm going to show underneath that I am dividing each of these by 3, and then I'm going to actually do that math. 9 divided by 3 is 3. 12 divided by 3 is 4. So the ratio of sugar to flour is 3 to 4. Now, once again, I can do this with the word 2, and I'm just going to skip to this piece. I can do it with the fraction. If I do sugar to flour, if I were to write it as a fraction, it may look something like this. Okay, and then with the picture, I do want to use the simplest form. So I would do my 3 sugar and my 4 flour. Okay, so now the next one is writing the ratio of flour to sugar. So flour to sugar, there's 12 flour. There are 9 sugar. Again, I would want simplest form by dividing both by 3 to get 4 to 3. And I'll just write those out in the different forms that we have. Notice again my boxes are lining up. Okay, so now we're going to write the ratio of the sugar to the total tablespoons used. So I'm going to start by finding the total. To find the total, I'm going to take the 2 numbers and add them together, which gives me 21. So I'm going to do sugar to total. The number of sugar are 9. The total number is 21. Now once again, stop and check to see if this is in simplest form. 9 and 21 can both be divided by 3. So I'll divide them both by 3 and get 3 to 7. So again, I can write that with the word 2 instead. I can write it as that fraction, 3 to 7, or I can do my tape. Okay, and I would always just stop and check to make sure that you did do the correct number of boxes, so count them out to make sure they're the right number. Okay, and then the last one is asking for the ratio of flour to total tablespoons used. So we've got flour to total. I always also too, I didn't say this, but I've been doing it the whole time. I also like to label my ratios first before I actually put in the numbers. So I'm doing flour to total, or F to T. For flour, it was 12. For the total, it was 21. Same total, hasn't changed. I'm going to divide both by 3 because they can both be divided by 3, which gets me 4 to 7. Again, I can write that with the word 2, with a fraction, or with a tape. Okay. Again, important piece here is simplest form. Okay, so now we're going to look at some other examples. This says, at the back-to-school picnic, there are 120 students, 45 teachers, and 50 parents. I'm going to start by putting an S above 120 students, because that's the letter I'll use to label, T for teachers, and P for parents. Okay, letter A asks us to write the ratio of the number of parents to the number of students. So this time I'm doing parents to students. So if I look back into the problem, the number of parents is 50. The number of students is 120. These two numbers are not in simplest form, so I'll have to start by doing that. So if you look at these two numbers, they both end in a 0. If you have a number that ends in 0, that means it can be divided by 10. So I'm going to start by dividing both of these by 10. And when you divide a number by 10, all you do is take the 0 off of it. So if I do 50 divided by 10, I'm going to take off that 0 and turn it into 5. If I divide 120 by 10, I'm just going to take off that 0 and make it 12. Since 5 and 12 don't have anything else that they can be both divided by besides 1, this is simplest form. Okay, and then once again, you can also write it with the word 2 as the fraction. You can do this one as a tape diagram. We tend not to do tape diagrams when the numbers get really large, and 12 is kind of a big number to be drawing that for. So unless it specifically states you need to draw it with a tape diagram, one of these 3 methods is absolutely fine. Okay, so the next one is asking us to write the ratio of the number of parents to the number of teachers. So now we're going parents to teachers. And again, order is important. Parents, there are 50. Teachers, there are 45. Looking at these two numbers, this is not in simplest form. One of them ends in a 0, one of them ends in a 5. If a number ends in a 0 or a 5, it can be divided by 5. So I'm going to divide both of these by 5. 50 divided by 5 is 10. And 45 divided by 5 is 9. 10 and 9 do not have a common factor besides 1, so 10 to 9 is a simplest form ratio. I can also write this as 10 to 9 or 10 to 9 with a fraction. Okay, so for the next one, we're going to write the ratio of students to the total number of people at the picnic. So what this means is I have to find the total. The total does include the students. So I'm adding all 3 numbers together, the students, the teachers, and the parents, in order to find my total. And I get 215 as my total. So to write my ratio, I'll be doing students to total. The number of students is 120. The total number is 215. So I notice one ends in a 0, one ends in a 5. So I'm going to divide both by 5, because that's what they mean. They can be divided by. I'm going to pull to the side to show my math. You can also use a calculator to do this. We get 24, and I'm just going to pull down here to do this, and 43. Okay, so now what you would want to do if you weren't sure if they had a common factor is I would think of the factors of 24. I know 2 can go into it because it's even, it can't go in here. 2 times 12, 12 can't go in there. I would keep going through 6, nope, 6 can't go in, 8, 8 can't go in, and so forth to see if it has a common factor. This one does not, so this would be my final ratio for that. And again, I can write it with the word 2, or I can write it as a fraction. This one I definitely would not want to draw with a tape diagram because I don't want to draw 24 boxes and then 43 boxes. Too many. Okay, so then the next one is the ratio of the total number of people at the picnic to the number of parents. So I've got my total to my parents. And I just kind of realized that I have T for 2 different things here. So maybe you even want to do like TO for total or something just to distinguish it between the 2. So now for my total, it's the same total, the 215, to the number of parents, which I have as 50. Once again, they can both be divided by 5. 215 divided by 5, we've already got that math, it's 43. And 50 divided by 5 is 10. So we've got 43 to 10. These do not have a common factor. So that is our simplest form. We can write it with the word 2 or as a fraction. So important pieces of information with ratios that we've seen so far is order matters. You must have the correct order to be considered correct. If you flip the numbers, it's wrong. It's not a correct ratio. They also need to be in its simplest form. That's going to be huge this year to make sure that all of your ratios are in simplest form. Example 4 says, at the principal's breakfast, there were 40 donuts placed out. At the end of the breakfast, 24 remained. So we've got 40 donuts that were placed out and 24 that remained. We want to write the ratio of the number of donuts placed out to the number that remained. So these 2 numbers are straight from the problem. We've got placed out, which I'll put P for, and remained, which is 40 placed out to 24 that remained. Need to put this in simplest form. I can see they can both be divided by 8. So I would get 5 to 3. Okay, and again, you can do any of those methods. You can even do the tape for that one. There's not too many. The next one is to write the ratio of the number of the donuts taken to the total. Now, in this case, the total is going to be the number that were placed out in the beginning. That's also known as the total number of donuts that there were. But what we have to figure out here is the number of donuts that were taken. So if we started with 40, and at the end, 24 remained, to find what the difference was, I'm going to subtract those 2 numbers. So I'm taking the total, which is the number that was placed out. That's how many we had total originally. Subtracting the number that remained, and that's going to give me the number that were taken. So a little bit of thinking on that one. So I'm going to do taken, and I'm going to still call the total placed out. So taken is 16, placed out was 40. I can see both can be divided by 8, so I'm going to be putting it in simplest form as 2 to 5, or 2 to 5 with the word 2, 2 over 5. So the big piece here is actually reading what it's saying as well. So we had to do some math to figure out the missing number. Write the ratio of the number of donuts taken to those that remained. So we have the number that were taken, and we also have the number that were remaining now. So taken we found to be 16. The number that remained was 24. Both can be divided by 8. And we get 2 to 3. 2 to 3, or 2 to 3. Okay, so again, make sure you're reading carefully, you're following the correct order of the ratio, you're putting it in simplest form, and you're doing any math that you may need to do in order to find any missing numbers, such as a total, or as in this case, how many were taken.